Before particles reach our lungs or pollute the air, engineers intercept them. One of the oldest yet simplest tools in our arsenal? Gravity settlers. In this video, you'll learn how these devices help clean industrial air by using gravity. A gravity settler is an expansion chamber. As dusty gas slows down, heavy particles fall out of the gas stream and settle at the bottom. They're great for large particles, but ineffective for fine dust. Particles fall because of gravity while the gas moves horizontally. If a particle's settling distance during its residence time is greater than the chamber height, it gets collected. Engineers use two models to estimate efficiency: the block flow model, known as ideal plug flow, and the mixed flow model, which is more realistic. Imagine a particle moving with an average velocity, V average, entering the chamber at a height, h, above the chamber floor. The time it takes for the gas that entered the chamber, along with the particle, to travel through the chamber in the direction of the airflow is T equals to L over V average. During that time, the particle will settle by gravity at a distance known as the vertical settling distance. Thus, fraction of particles collected or settled down before it reaches the end of the chamber is the fraction of its vertical settling distance to the chamber's height. Engineers use models to predict performance. In the block or plug flow model, particles have a clear, linear path. In the mixed flow model, turbulence causes mixing, so predictions are more conservative. There are several design variations of gravity settler to improve its efficiency. Multi-tray. The multiple tray settling chamber is also called the Howard settling chamber. Several horizontal collection plates N are introduced to shorten the settling path of the particle and to improve the collection efficiency of small particles, as small as 15 millimeters in diameter. Each shelf or tray in the unit can collect dust that settles out by gravitational force. Baffle chambers. A variation of the gravity settling chamber is a baffle chamber, sometimes referred to as an inertial separator. These units have baffles within the chamber to enhance particle separation and collection. This arises by changing the direction of the gas velocity and imparting a downward motion to the particle. Elutriators move air upward to remove lighter particles. An elutriator is a slight modification of the gravity settler. The unit consists of one or more vertical tubes or towers through which the dust-laden gas passes upward at a given velocity. The larger particles that settle at a velocity higher than that of the rising air are collected at the bottom of the tube, while the smaller particles are carried out the top. In order to vary the air velocity, several columns of different diameters are used in series to bring about more refined separation.
Another modification of the basic gravity settling chamber is the gravity spray tower, a wet unit that employs water. When a moving dust-laden gas stream approaches a body, such as spherical droplet of water, the gas will be deflected around the droplet. The dust particles, by virtue of their greater inertia, may impact and be collected on the surface of the droplet that is falling under the influence of gravity. Gravity settlers are low-cost, simple, and reliable. But they require a lot of space and can't handle fine particulates effectively. They work best as pre-cleaners before high-efficiency devices. Gravity settlers are used as pre-cleaners, reducing the particle load before finer control devices like cyclones or baghouses. Designers must keep gas velocity low enough to prevent re-entrainment but high enough for a practical chamber size. In the next video, we'll explore cyclone separators, devices that use swirling motion to separate particles from air with greater efficiency. See you there.